us at Math for All in those spaces. And we try and put in comments as well if you have them. So feel free to follow along in those ways.
Yes. Yes. And as usual, we are super excited about our guests. We get to talk to the coolest people. So we're never lack of excitement around here. So we are going to be talking to Tyrone Martinez-Black today about how we can use words to unlock the magic within mathematical reasoning. So he is going to have a lot to say about that. And I am going to read his bio. Tyrone Martinez-Black is an artist, mathist, and edifist. They have taught middle school math and science, coached and directed department for those subjects, as well as delivered adult learning integrating academic disciplines with social and emotional learning, equity, and Dane thinking. Tyrone loves to play with words, and every once in a while, they win. So let's bring him in.
Hi.
Hello,
Hello,
welcome.
hello. Thank you. Thank you for having me.
Welcome. We're so happy to have you here today.
I appreciate the invitation. I'm excited.
Yay.
As are we. So we'd love to start off with this question, in part because it lets everyone, if they are not familiar with you, get to know a little bit about you and your background. So what's your math story?
So this particular version is going to be a little bit of a ramble, maybe, and which people who do know me know that that's not surprising. But I'm going to start really with this idea of migration, what it means to move, and about the world in a kind of way. And so I start there because it's very important to me, sitting where I am in the suburbs of Chicago, to kind of recognize that this land was once peopled and continues to be peopled by primarily the Council of Three Fires, which is the Ojibwe, the Ottawa, and the Potawatomi people. And that's important not just because of our penchant these days for acknowledging the land, but also because here in Chicago, that settling or moving is very important. In particular, as somebody who is Black in my heritage, the idea that Chicago was founded or initially settled by DuSable, right? Depending on the stories told, French Canadian or Haitian, but certainly Black, who married a Potawatomi woman in the late 1700s. And that becomes important for me because it mirrors the arrival of my father, who is Black, from South Carolina, and eventually going to school and meeting my mom, who is of Mexican descent, whose family, whose grandparents arrived here in the 1900s from around the Guanajuato and Querétaro areas in Mexico. And so Chicago is a center of people who know the history, the transport through the rail yards, which is eventually where my grandparents settled, my great grandparents, that is, called the back of the yards, right? And so the reason I bring all of this story into the equation, so to speak, is because then the meeting of my parents, having me born here in the Chicago area, and then moving very quickly to New York City, where I was in Brooklyn until about 7 years old. And so I tell all of this kind of geographical positioning as a way of highlighting that my math story, kind of couched within my entire life story, is one of kind of moving about, changing places, being in different spaces, and adopting, frankly, different identities and modalities. And so when I think about specifically what it looks like to look at myself from a math kind of perspective, I was a decent student, went through all the classes, kind of did all the exercises with some, I guess, amount of ease. But I didn't really pay that much attention to what we would later call a math identity, right? Or call myself a math person. And in fact, when I arrived in college pursuing civil engineering at first, that was only because I had been successful in my math and science classes, and my high school counselor said that would be the thing to pursue. What I learned, however, is that my academic training had not been as strong as I needed it to be to go distant to a university in another state, be away from my family, and kind of struggle through kind of a new independent academic rigor, right? And so I proceeded to fail a lot of my math classes, actually. And so at that point, a lot of my mathematics sense of self was rooted in having been kind of easily successful and so forth. And so at that point, I diverted to an original love of mine, which was design and architecture. And when I was going back to that story of going to Brooklyn when I was young, at 5 years old, I had declared to my mother that I was going to be an architect. And as it turned out, I didn't really know what that meant.
Well,
Exactly.
how did you know what an architect was at 5 years old? That's
No,
kind of
yeah, absolutely. Thanks for that question. Because what I knew at the time was that buildings were fascinating. If I'm not mistaken, I had a children's book by the author Richard Scarry, and it had a kind of how-to or what's inside type book where it had cross sections of big ships and skyscrapers and what have you. And I was fascinated by the makings of things. And so I imagine that I picked up that word from frequent trips my mother and I used to take to the Barnes and Noble in New York, and somehow that word got in my head. I also read a lot of comic books, and a tip to parents and caregivers out there is let your kids read those things, because they tend to use a lot of vocabulary that the unsuspecting youth don't realize they're picking up. But so at any rate,
by the comic book learning.
That's right. Comic book learning. I found my way to university. Did not do so well at the civil engineering thing, but returned to kind of design, and it was some of that aesthetic arrangement that was really appealing to me, which ultimately led to pursuing other endeavors that were, artistic and what have you, which had always been a kind of love of mine as well. So I mean, like, as I said, a little bit of a ramble. I think I returned, maybe to close this particular chapter, to teaching math and science, actually, after I had graduated with my fine arts degree. Chicago Public Schools needed a cadre of math and science teachers, very underserved discipline in the schools at the time. And so I entered an alternative certification program. I had all of the credits to qualify me, and then resumed now as an adult in a second career after a detour of installing telephones, which I can go into that some other point. But at any rate, it rekindled kind of my attention to numbers and quantities and patterns and relationships in such a fashion that it was really one of those things where you recognize you're learning as you're teaching. So to now enter into middle school mathematics teaching just reopened a new attention for me to mathematical concepts and the ways that they relate to a variety of other disciplines. And so, I guess that's at least one leg of the journey.
Wow. Can I just say, you're super brave to not commit to teaching at first and then go to a middle school, most people would say, I'm calling you brave because I'm nice, but I think most people would say you're crazy.
Well,
I was a middle school math teacher, so I know.
I know. In my family, my grandmother and most of her sisters were all in education in some form or another,
Okay.
and I, as one does, did everything I could to avoid the so-called family legacy in that respect. But you know, it resurfaces in a lot of ways that whether one is a classroom educator or not, there are, and this is what where the term edifice comes from, right? Is it for me? I find myself called upon to build people up, right? And so whether it was classroom, whether it became professional learning, as I eventually moved on to, and other kinds of administration level work, helping other people be better versions of themselves was something that I felt compelled to, and in that way was edified myself. And so, you know, I think that, yeah, middle school math is and science is a real thing.
It's no
It
joke.
absolutely is. So I wonder, do you think that your experience with reaching a point where there was some struggle within like math as a whole in college, how do you think that shaped the teaching that you do or have done since within the math classroom? Like I want to.
Sure.
Awesome question.
Yeah, so partly I would say that much of my identity as a person was edified by, you know, a very rich and supportive home, and relatives, relationships, kinships, and so forth. And so I was really shook without question that I was not doing as well at a subject I believed I was expert at. But I had a good deal of feedback from colleagues, peers at the school, and mentors and professors who recognized a whole host of other sets of geniuses, right? To use Goldie Mohammed's framing, that this is one kind of setback where there's all these other abundant tools, talents, and what have you to draw upon. So reinforced in a lot of ways by some of my very best friends, closest relationships through school, even though I was struggling in classes, I was affirmed in the being that I was, and kind of the becoming that I was engaged in. And so when I eventually ended up in the classroom, I had, as I mentioned already, I had detoured through working for the phone company. I had detoured through attempting to learn how to fly planes. I had detoured through arts and all manner host of things. And so what I kind of accumulated in those life experiences was a certainty that the academic trajectory wasn't of itself the only valuable thing about learning.
Yeah.
Right. And so when I talked to my students, then I had greater than a conversation about, well, this will get you to the next class, or this will get you to the next school, or this will get you to the next level, or this will guarantee some kind of profession, because I had already changed multiple careers, multiple ideas, multiple disciplines. And so I had some experience with that. Oh, I'm seeing this sunlight. Let me just close this really quickly.
I thought it was some special effect that
it was slowly rising,
moving up as you went. I was like,
buffering my signal somehow. Okay, so that was, you know, to then talk with my students. It was really interesting because they almost insisted on the conventional norm, right? They saw me as then this knowledgeable other from whom they were supposed to get all the things that they needed. And it took a lot to kind of work through, well, what are we really here together in relationship to do? And how do we think about greater than computation? How do we think greater than sets of skills as if they're just steps in a process, which fully, at your invitation to be here today, is what brought me to this idea of mathophoring, right? This notion that there's linguistics, right? There's language that we use, symbols that we use, and we tend to think of analogy, for example, in language arts, as a means of kind of comparing and making sense of what we understand. In math, we do the same thing, right? And I think sometimes people oversimplify to, well, just ratios and proportions, right? That those are kind of these analogous relationships. As 2 is to 4, then right, that 8 is to 16. However, what I found was really also quite compelling for a lot of my students is that to make the learning relevant, we're also talking about translating concrete experience into abstract notions, right? That representational domain, which is where metaphor lives, right? Where simile lives. And so for me, having some skill with the use of these words, I found that I was able to help translate concepts to my learners in ways that they hadn't experienced before, certainly. And as I continued to grow and develop and deal with my colleagues in other classrooms and beyond in the greater kind of mathing community, it became clear that I had my very youthful fascination with puns, for example, was really helpful for illuminating ideas. I would share one with you, which is, just a kind of a riddle, which is, when is sum equal to all? And that only works if you're using the homophones, right? That is SOME with SUM, right? And so it takes a wordplay that then trying to make sense of gives you an insight into, what is in fact the difference between parts and wholes? What is the difference between some? Why does some mean all? And I would say something that students don't get a lot of advantage of is the use of more words rather than fewer words, right? We try to make things accessible so often by trying to find the simplest word. And in reality, it's in specificity that we gain greater, comprehension, because there's snow, and then there's wet snow and dry snow and powdery snow and dirty snow, and and so on. Go ahead, Molly. I'm sorry.
No, it's interesting that you were saying that about the words, because I feel like when I first started teaching, we were transitioning to standards-based, and with standards-based programs came a lot of words, and your book would come and it would have paragraphs and lots of questions with lots of words versus just lots of numbers. And I remember that being really jarring for teachers, parents, and kids. And eventually we chose this program because it was supposed to give this great understanding, and it was, lots of stories and blah, blah, blah. And as soon as the teachers that chose that program were marginally gone, so was the program. And it's just so interesting because in order to understand math, you really do need more words, but reading comprehension steps in the way sometimes of that. Have you even asked your question yet?
Not yet.
We should get to that. Remember I told you we're chatty?
Yes, absolutely, absolutely. Well, you're talking to a talker, so it's
Yeah.
all good.
It's all good.
So let's do it. Let's actually talk about your question. So how can we use words to unlock? I mean, you're already talking about this, but to
For sure.
unlock the magic within mathematical reasoning.
So returning slightly to the idea of a pun, right? Is so, sum is equal to all. Another one would be, our prime time shows only on 2, 3, 5, and 7. Those types of, again, word plays help us to reconceive, right? Like, to slightly adjust our mind frame enough to wonder what is actually underneath our conception of these numbers and their relationships. And so I do this quite a bit. It recently, or over the course of the last several years, for example, I made and wore a couple of T-shirts, one of which was that math is the new black, and the other is that the new math is black, right? And so these ideas, just they're word arrangements that can help stimulate an additional set of thinking. The reason that I call it mathiforing, or the reason I think of it as unlocking some magic in the mathematical reasoning, is not to make it less scientific, so to speak, right? Not to make it less solid and real, as I think some of our more professional colleagues would want. The technical aspects of mathematics are always going to be there. They're a series of kind of arrangements, assemblies of symbols and numbers and what have you, to try to make sense of the world. That will always persist. But what isn't always available for our youngest learners is the idea that it is malleable, right? That the idea that it can actually be constructed by their own practice. And so when we think about something like magic in the even fantastic sense, right? The fictive sense, it's rooted in actual practices of what we now think of as primarily indigenous and aboriginal locations, right? If we think about, for example, African conjuring, the idea is that objects, words, gestures are themselves not the magic. It is the intention underneath, right? It is knowing that this word stands for something, that this gesture corresponds to something, right? That the object carries with it the full intentionality of what's being done. And so when we think about mathematics that way, then what we're saying is that we have this symbol, and I'm just going to do this, right? And that symbol is a zero, a circle, right? A point equidistant from, right? It could be anything. And that anythingness is where the magic lies, because it takes understanding why this particular gesture gives me zero, which may mean nothing, which may mean something, which may mean, right, all of
360.
those things,
Yeah.
360 degrees, right? And so in that respect, what we would look at, and this I'm very fond of, working with my colleague, Dr. Brandy Ward, and the queer mathematician, and thinking about this idea of fluidity, right? That all concepts are available to us to shape and to mold and to invest with meaning, that sometimes means something here, sometimes means something there. It's this capacity to, and going back to my math story of migration, right? It's our capacity to traverse different ideas that give us our greatest power and our strengths. So when we use the words, we could be saying it's one, but one what, right? So to another, co-learner, Christopher Danielson, and unit chats, and how, which one belongs, and so forth. Those ideas is to say, if I have one, I have to ask one of what, right? In order to then translate. And so this is where, again, words and what they mean start to unlock the capacity to invest other meanings in our computations, in our quantities, in our ratios, and so forth. So
that's so important to talk
go.
about when kids that's so important to talk about when kids are real young, because when you get to middle school, some of your mathematics that you've learned gets undone. And then also there are more meanings to things, right?
Well,
I can't even
absolutely.
think of an example right at this moment, but
I
probably
have the perfect one for you, right?
Yeah.
So when we tell little children, for example, things like you cannot subtract
Mhm.
larger numbers from smaller numbers.
Yeah.
Like
Mhm.
I mean, I almost want to, like, it's visceral. It's
Yes.
physically, we're saying it is an impossibility. And yet we know that in time, they
Mhm.
will come to unlearn that,
Mhm.
right? And so what we would potentially say instead is that right now we are going to concentrate on numbers that are easy to subtract,
Mhm.
right? Are easier to subtract, or have representations in real whatever words we use. I think partly what we have to recall is that the discipline, the apprenticeship that
Mhm.
mathematics learning represents, is, if you imagined it like a sorcerer and their apprentice, it is follow these gestures, but I am not going to use words and gestures that are different than the words and gestures I want you to understand.
Mhm.
So I would not use, um, you know, the
Integers.
idea. That's
Yeah.
right. So in fact, I am of the school that says you might as well call them
Yeah.
add-ins the first time you talk about them. You might as well call them integers the first time you talk about them,
Mhm.
because that is the word that the student is going to learn regardless.
Mhm.
So in complement to that, and this is the key part for me in terms of the mathophering, which is then when a student says, I plussed it, for example,
Yeah.
that has to be a perfectly acceptable
Mhm.
linguistic mode,
Mhm.
Mhm.
right? I timesed it. Whatever it is they say has to be accepted in the bounds of this kind of alchemical cauldron, right?
Mhm.
We're turning these words into significance,
Mhm.
right? And so if they can be convinced early on that that is in fact their role as a learner,
Yeah.
right? To constantly transform ideas, symbols, words, images into some new sense, they become powerful in their wizardry, frankly,
Mhm.
right? They become powerful in their capacity to shape their reality, because they know that these symbols are no different than these other symbols in terms of their malleability, right?
Mhm.
Their capacity to hold thought. So then when we get to algebra, the idea that an X is a container for things, they
Mhm.
should already understand that that symbol that looks like a 3 is already a container for the concept of 3,
Mhm.
Mm.
right? That symbol is not itself 3, right?
Right.
And so we arrange symbols. And again, this is where the parallels and the mathophor to the magical realm is. That's a spell, right? Literally, it transforms these symbols and gestures into computations and quantities. So
Right, but now you just gave me another thought. Because when you get to middle school, right, you can represent multiplication in so many ways,
Mhm.
absolutely,
where you've only been able to represent it in one way up until then, right? So
that's
you
right.
can use an X, you can use a dot, you can use parentheses. So you can use exponents. I mean, there's so many ways to represent it. And if you don't have kids start in the younger years understanding that there are multiple ways not only to think about things but to operate with things, and everything that you're talking about, then that becomes really difficult for kids to
Mhm.
understand.
Well, so, and what's fascinating even about that is that it's not to say that there are no rules, right? It's to
Mhm.
say that the rules
There's a lot
are
of rules.
territory to
Yep.
right?
Yeah, yeah.
They're not that they're boundaries like fences. They're boundaries like stepping across the state line,
Mhm.
right? Like they exist, but they're movable. And so I think the recent example of this new aperiodic tessellation
Mhm.
is a fascinating example of what I mean, and go back to what I was saying about the kind of queering of mathematics and this fluidity notion, which is that the tile itself, tessellation, is a fairly formal kind of concept, right? It's
Mhm.
this thing, this object, this shape, this figure can repeat without gaps,
Mhm.
and we call that, you know, periodic tessellation when it does so in an easily identifiable pattern. So someone came along and said, well, what if I just kind of bump this edge out and I tuck this corner in? And
Yes.
right, it's built on underlying the equilateral triangle,
Mhm.
but the end shape, which is this collection of triangles, now when you kind of turn it and place it with another one and turn it and place it, you get these oddly beautiful but irregular,
Mhm.
right, arrangements.
Yes.
That right there is, in my view, that like real definition of this kind of magical territory, this queer and fluid territory that allows for things to both be true and untrue simultaneously,
Mhm.
right? And so this then is why then the mathophoring works, is because I can say it is simultaneously a repeating figure
Mhm.
and it is a chaotic figure right at once.
Mhm.
And because of that, things like imaginary numbers, the first evidence of the arrival of zero in our lexicon, right? All those things were mathematical, again, philosophical
Mhm.
concepts that we knew had to exist. And until we kind of figured out a way to describe them, we just lived life without them. But
Mhm.
once we had them, they unlocked something that we could do with even greater power, right? And so you end up with you know, the symbol I for, you know, the square root of the -1 and so on. That I doesn't mean anything until we say it means
It was
this,
something, yeah.
right? And so that is what this powerful kind of magical reality shaping mathematics can be, is that you end up with things like the fuzzy logics that let us shoot rockets at planets that aren't going to be there for millennia, right? Like those are the ideas that
Mhm.
we have to allow for young people especially to live in their imagination and recognize that the relationships that they believe they are making are worth investigating.
Mhm.
And we can only do that if we have this kind of analogous reasoning, this representative reasoning, this what I'm calling mathophoring. So in that full context, you know, I hope that that's at least clear as a beginning of understanding, you know, why it's so important for us to use not fewer but greater numbers of words,
Mhm.
greater flexibility of symbols, so that people can adopt ways of telling their stories as they kind of migrate through their different levels of understanding.
Mhm.
Just so screams that we need to have kids doing more talking in class,
Mhm.
because like what you were saying before about, you know, kids using the timesing and plussing and all of that stuff, it they're making sense of what they're doing with the vocabulary that they have. And if we do allow them to use that vocabulary, then they can make more connections with kids that are sitting right beside them. And
Absolutely.
that's a big part of what you're talking about. And I feel that it's not encouraged enough because teachers are often afraid of giving kids the reins.
Mhm.
Well, so that right there, right? So you call for us to do more talking, certainly, but also more drawing, right?
Mhm.
Also more
Oh,
practice listening, more practice interpreting, right? And what you just described becomes a significant equity issue when we talk
Mhm.
about you know, concepts of my colleague Olivia Mulcahy really leans into a scholarship that's called translanguaging, right? This idea that, you know, it's not simply about needing to learn English or
Mhm.
needing to learn a different, it's about the plurality of our tongue, right?
Mhm.
Literally, that we're carrying our culture, our meaning with us, as we migrate the world. And so when we have learners in front of us who are using whatever words, symbols, images that they use,
Mhm.
they are at that moment a migrant in the mathematics discipline. They
Mhm.
are bringing all of themselves to this territory of mathematics learning. And Deborah Parrott calls it
Mhm.
math, the mathers,
Yeah.
right?
Yep.
Like to kind of adopt that identity is to become fluent. This is where that language, that become fluent in the language of the land. And
Mhm.
what we cannot do, however, is convince young people that that language is fixed,
Mhm.
right? That
Mhm.
that language isn't, in fact, particularly here we are. Sorry, am I getting?
No worries.
Um, this language of oh wow, sorry. Um,
Totally fine.
We're casual here.
Okay. So anyway, so that idea of fluency is not just about learn how to use these words.
Right.
Fluency is about being able to translanguage, right? Being able to
Mhm.
comfortably sift through what your choices of words might be so
Mhm.
that we can make meaning together.
Mhm.
And so that's where just for those of us who do speak English or this form of English in 2023, right, without acknowledging that it is an assemblage of a variety of different
Mhm.
words from different places in the world would be naive at best,
Right.
right? Or and so this idea that the use of a greater array of words is where we unlock really the power for young people to make the meaning that they would.
Mhm.
So yeah, I'll pause there again.
Yeah, and so much language, continues. It's not static. And so that idea, like, I get concerned sometimes. Like, while I want students to have access to, I don't want to dumb down the language. I want to make sure that they have
Mhm.
access to academic vocabulary, and I'm using that in the classroom so that they have, it's an access to me. It's like that's an equity thing. But I can't be like, oh well, you're timesing, and then if I shut that down, I'm
Mhm.
taking away their part of their identity, part of their language, um,
Part of their expression for
development and
understanding.
thinking around that. And so I think, there's this attend to precision piece. I think sometimes those standards for math practice get us into a little bit of trouble. I have some issues with perseverance too, but
Sure.
that precision piece of it is like, what is that really? Sometimes it's not a single word. Sometimes it's this whole picture of language and drawing and interconnectedness that is not a single thing. It's
Sure.
all of those things that allow us to attend to precision in that way.
Well, the fun thing about that word even is twofold for me. One is that a precision is a process, right?
Yes.
Like it
That's what
it
I.
is the attempt to home in on
Mhm.
what exactly is being said. The other thing is that its roots are in the same word as scissors, right? Like
Right.
it's to be, it's to
Cut.
kind of cut, just the right way, right? And so um, th- that linguistic precision, I think, becomes re-examined or examinable when you think of yourself as a traveler, right? Which is why I told the story, my math story, as one of migrating, because there are going to be times when I'm in another land that is either unfamiliar to me or I don't quite have the facile linguistics, right? So I do my best with a combination of gesture, the words I
Oh,
know, and so forth, in hopes that the other person is receiving me with some grace and some kindness, right? To accept that I am trying my very best to be understood and they are doing their very best to understand. And I think that what we lose in the idea that precision is only about using the exact word or the correct word we miss on the idea that what we're trying to do is find the word that helps, right? The word that moves us in our common understanding.
That's so true.
Mhm.
Can I
And
give you a funny example, the way that you just described that? So I was just in Italy and I was trying to get something for breakfast without an English menu. And they had all these pastries, and I'm allergic to hazelnuts, and hazelnuts are everywhere there. So I was trying to ask the man, and he didn't speak a whole lot of English. And I was like, does this have Nutella? And he was like, I was like, he's like, no Nutella.
that's right. That's right.
So it's like it's like exactly what you just said, right?
That's right.
I mean,
That's
and
right.
I think we can absolutely expect kids to use the vocabulary that we are supposed to teach. But in the learning process, I don't think that while they're still learning that concept, they need to use their own language to make sense of it. And then we can say, yes, and this is how you describe what you just said. But I think it's a kind of a fuzzy area, right? Like almost like at the end of the year, you should be able to use all these words, but up until then, you can use whatever kind of language gets you to that point.
And even after, I mean, the idea, very common in I when I was younger, I studied French when, being of Mexican.
What have you not studied?
Anything I can get my hands on, right? So being in a Spanish speaking family, occasionally I did not grow up having to speak Spanish, but definitely attempted to learn it with greater fluency later on. The idea, I bring that up only to say that one of the most common phrases one learns is, how do you say?
Yes.
Yes.
Right? Or what is this thing? Right? So como se dice, or qu'est-ce qui se, right? Like what we're trying to do is say, we know this thing, this object, and we want to know how you call it.
Yeah.
Right. So if we allow for that as adults transversing the world, then we certainly should allow that room for young people as they're trying to say, okay, I have this object, this idea, this sense of things, and I have this word for it. You might have another word for it. And until I recognize that more people use the word you're using than I use my word, I will use my word. And I think that partly it's not about, well, everybody at some point has to eventually just call it equations, or everybody at some point has to just call it, well, certainly. Or we could say, while we're in this space together, we will use this word so that we understand we're saying the same thing. That doesn't make the word better or worse or what have you. It's just, we call this thing ketchup. We call this thing tomato paste. We call this thing, right? Like, and so it just becomes a willingness to allow for the kind of amorphousness that meaning making actually requires. And so I'm all for, just adding to the instructional repertoire, what's your word for this, right? Like, what do you call this? So that kids can get in on the action of casting some spells themselves.
I love it. I love it.
I think one of the classrooms I've spent quite a bit of time in has a number of students who are fairly recent arrivals from Ukraine and from Brazil or others, or Portuguese-speaking countries. And one of the things that's been so interesting is it's a 6th grade classroom, but they were reviewing some things with the standard algorithm. But and they're like, well, the teacher's like, well, the standard algorithm. I'm like, you mean the American standard algorithm? And that teacher and I were talking, she's like, oh yeah. She's like, I've learned all of these other ways that other countries do this, that is their standard algorithm. That's not like, it's not the American, it's not the standard, it's N.
Yeah. No, I love that, Heidi. The idea that we can just switch articles and completely
Right.
change the way
Yeah.
we do things,
Yeah.
right? So get off of the so much and allow for a or any
Yeah.
would be immensely powerful for people.
Yeah. It's like, just like opening that up a little bit, and I think that's part of the problems, so much of being in the US is that we get so focused in on just our way of doing things. And there's a much larger world
Mm.
out there where people do and say, and it doesn't make that any less mathematical or magical or important than what we do here. And so just opening that up a little bit, I think is just really critical to the work that we're doing.
Yes.
Yes. Well, this has been amazing. So our listeners, although I do have to say, some of our current listeners are your pals, I think, because Chris says, love the history lesson about your math story. And Nolan Fossum Math says, hey, y'all. So,
Nice.
so they probably don't need to know how to learn more about you,
But
but
for everyone else,
for
for
everyone
everyone else.
else, where can they learn more about your work?
So the locations you would find me are on Twitter primarily at the teachnext_TMB and a website often a tangent at WordPress.com. I think what I would say is a handful of just closing remarks there, which is I don't think I put the Instagram tag, but it would be the teach next, but a dot instead of the underscore TMB, and that will be Instagram. And what I do there is take lots of pictures of interesting mathematical patterns, and kind of push some boundaries on what it means to count. Ask the question, how many? And so, in any event, the work that I would really want people to be thinking about that I'm engaged in right now is on the platform of Twitter. We have hashtags all the time, and I've recently been kind of interrogating the idea of place value. And so with hashtag place value, we're looking at ideas of what it means to have a number system that is, well, all number systems, frankly, but just using our base 10, that power is based on proximity to 0, right? And positionality matters, right? So we go back to what I was saying before, like you have that symbol that looks like 3. When it's in the ones place, right, we're giving it a corresponding value based on its position. When it moves to some other power, it is the same digit, but it carries with it a great deal more power by magnitudes, right, of 10. That is correspondent in a metaphoric way to how we individuals in society, in civic work, in civic relationship, are powerful in proximity to places as well. We talk about what it means to have a civic center, for example, and a colleague of mine, Tanika Johnson, here in Chicago, has a folded map project in which she looks at Chicago as a grid system that has an actual origin intersection. And so when you're on the south side of that grid, corresponding property values are much less than when you're on the north side of that grid. And so you can actually have a conversation of relative distance from 0 and what it means in terms of actual lived experience as proxied by property value, right? And you talk about the geography and the geometry of redlining and so forth, right? And so hashtag place value. Our colleague Marian Dingle and I were intending to prepare for the centennial of the NCTM at Chicago, and the idea arose that conferences like that could do very much better to actually engage in the locality that they're landing upon, right? So rather than being kind of a satellite arrival that is only taking place at this mega hotel, with maybe some recommendations to enjoy some nearby food and tourist attractions, what would it look like if we actually invested in the communities and the kinships of people who are in that community? And so that was some of the origin of thinking about this notion of proximity, right, and positionality, and what it means to kind of be able to magnify power based on, you know, collections of ones into manys. And so so that's what I'm working on. I'm working on this idea of a non-academic dissertation, which is to say, I'll be doing some doctoral level study without worrying about catching some letters behind my name. And so Chris and Nolan and some of the people I've mentioned are in some ways my committee, and
Awesome.
so you know, as I continue to explore some of these ideas, will be holding me, you know, to some level of responsibility to them, and for which I'm deeply indebted to them. So yeah, so that's what I'm working on.
That's amazing. This has been so fun. And we're so grateful that you gave some time to us tonight.
I was thrilled to be here. Thank you so much for having me.
Yeah, great.
Well, thank you so much.
All right. Well, obviously we could talk to him for several hours.
Yeah.
And I wonder if he knows Sunil. I feel like he needs to, if he doesn't know Sunil, that seems really strange.
No, I like wrote down the map project. I'm gonna have to look at that.
Yeah.
So we have one more show this season.
No, I can't even believe it.
So it's going to be next week with Pam Harris. And so we hope that you'll see us right back here.
Yeah.
Same time.
Oh, next week. Yikes. That's quick. That's quick. All right. Well, until then, we hope that you make math creative, curious, and inclusive for everyone.
Good night.
Have a great night.